Okay, guys. Today, we will review the cipher. Okay, the encryption of Vigenère. Uh, so let's remind ourselves what the algorithm is. Basically, we have to create a grid um, of this all these alphabetical characters. Okay. The example here, it shows A to Z. So we have to create a grid of rows of all the characters. Okay, and then each subsequent row is shifted to the left. So this one starts with A, next one starts with B, C, and so forth. Okay, gets shifted. So that's our first priority, to create the grid. Okay, so let's start creating the grid. Actually, so our program should behave as I explained in this assignment, right? So yeah, it should ask for a command to encrypt or decrypt, and if it is encrypt, we'll ask for the key and then the plain text, and then we'll show the ciphertext. And for decrypting, it's the other way around. It should always ask for the key, and then it asks for the ciphertext, and then gets the plain text back. Okay, so the way the algorithm works is that, as I explained, you have a grid of alphabetical characters, right? Shifted, subsequent rows are shifted by one to the left. So if you have this example here, this is the plain text that we want to encrypt, and say the key is lemon here. What we need to create is that we need to use every character in the plain text and the key as the index into this grid. So if we use A as the row index, we should use L as the column index. And so, for example, here I used A, right? It doesn't matter which whether you used the plain text as the row or plain text as the column, because this grid is actually symmetric. If you see it, it's symmetric. It's always ABCD this way, and then ABCD this way. So it doesn't matter which way you go. Okay, so that's one thing to note about this grid. So in this example, I used the key as the column. So for example, if I look at the first letter L and the first letter of the cipher, the plain text, so I will go into the column and go into the row and find whatever that value, that will be my ciphertext for that first character of the plain text. And the second character is T for the plain text, and second character is E for the key. So we go into the row and column and find the character, and that will be the encrypted ciphertext. Okay, so just to see if it works the other way around, like the row and column, if we shift it. So for example, this one is A. If I go this way, A and L, it's L, right? And T, if I go T here, T and E, he is here, T and E is X, same as here. Okay, so it's symmetric, so it doesn't matter which way you go, row column or column row. Okay, so let's get started. Let's see how we can code. Okay, so we need to start by asking the user encrypt or decrypt. Okay, all right, so I'll just create my main method, and I will call the main method. So obviously I need a initial while loop to keep asking the user. So while true, I will ask what did we say here? Okay, so this will be my command. Then I will check if command equal to E. I'm going to have to encrypt, otherwise I have to do a decrypt. Okay, so regardless of whether I encrypt or decrypt, I always ask for the key. So I would ask, as part of this the second statement, I would ask for the key here. So let's call this key string. Okay, now here I would ask the plain text. So that will be my plain text string. Okay, so for the moment we will just put pass for the else. So we'll focus on encrypting first. Okay, pass is a keyword in Python. Basically it does nothing. Okay, so if you have a statement like else statement where it needs something, you can just put pass for the time being if you don't want to show any errors, right, in the IDE. So let's see if it runs. Okay, E. Okay, so it keeps asking. Okay, so let's create our grid, right? So let's create the first row. Okay, so I'll create a function create grid. Okay, it doesn't take in anything. Yeah, well, let's take in the first row. Okay, it's easier that way. So let's create another function that gets me the creates me the row, the first row, to be specific. So we'll pass in the first row. So here I would say characters. So which characters do we want to go from? A, B, C, D. Let's go with the capital letters first. Okay, so I have a string. Now I need to convert this to a list of characters, right? One way I can do that is I will iterate through it for C in characters. So now I have the individual characters. If I want to put it into a list, I will just create a list initially. Say first row.
Is it supposed to be a colon or a semicolon?
Oh, sorry.
For the characters.
We don't need a semicolon. That was an accident. I'm used to doing Java, so I always put the semicolon. You don't need, in Python, you don't need to end with a semicolon for statements. Okay, so first row, so I just keep appending the characters. Now my first row has all the characters in the list, so I'll return first row. Okay, so now I have a function to create the first row, and this grid will let's go ahead and create the grid. Okay, so the grid, how many number of rows it will have? It's a square, right? So it should be the number of characters in the first row. That should be the dimension of the square. That's how many rows it's going to have, right? So let's say for how many times we want to iterate. Let's go from, let's just do a range. So we want to create a range, first row, length of the first row. Okay, so we have a range that's going to start from 0 for I all the way up to until 25, right? 25 characters in the alphabet. So here we need to create a new temporary variable called grid. Again, it's going to be a list, but the contents of it will be a list of list. So if you look at this, we somehow need to shift them, right? Basically the first row we don't have to shift, right? So I'm going to use this I as my indicator to determine how many elements to shift. Okay, initially it will be 0 because the range starts from 0 all the way to whatever we specify -1, right? So how can I do this? If you remember the list slicing, I can use the list slicing to get a slice. Let's say I is some position, right? I need to take basically, if my position is, let's say, E here, right? Let's say that's 0 1 2 3 4, fourth iteration. I would have to take everything from fourth iteration, the element 4 all the way to the end. So you can see E all the way to Z, then everything in the beginning up until E. So 0 to 4, right? So let's do that. So the slice would be, or actually the new row, right? Because we are the first row. So the new row would be first row. We have to go from whatever the index I all the way to the end, plus, right? Plus concatenates two strings to create a new string. First row. Here we need to go everything from the beginning all the way to I, but not including I, right? Remember the end parameter is excluding, right? The first one is inclusive, this one is exclusive. Okay, and if you don't specify anything, it goes all the way to the end. So this should give me a new row, right, for each iteration. So I just have to add it to my grid. So that at the end of this iteration, I would have my grid populated the way that I want. Everything shifted by 1, right? Any questions on this? Do you guys understand this? Let me see. Let me see your faces. Understand? Okay. So what do we need to do next? So we have the grid and the row. Let's create them up here. Okay, I don't want to create any global variables, so temporary variables I will create them up here. So I will create my first row. Okay, why would I need this first row? Let's create it. I need to pass the first row to the grid. Okay, so grid, create grid, and pass my first row. That'll create me the grid. Okay. Now, do I really need this first row, or can I just create the first row in this grid? Alright, I think I need the first row because what I'm thinking is that when we have a character, right? Let's go back here. When we have a character, we somehow need to know what index it belongs in, right? Here, if I want to go to the row, say T, how would I know what row the T belongs in, right? So I would need to create some sort of a map that tells me for each character what is the row index, right? So let's create a map for that, or a dictionary, right? Dictionary can right away tell me. So let's create a dictionary that's going to have a key as my character and value as my index. The index could represent either the row index or the column index because this is a square matrix and it's symmetric. The values are symmetric, right? So create index dictionary. So I'll pass in my first row, and I will just iterate through it. length of first row. Okay, so now I will tell me what the index is. So I will create this dictionary, index dictionary. How do we initialize? We put the curly brackets, right? And so index dictionary. Oh, I actually need a character here, right? My key would be my character, so I don't need a range here. I just need to iterate through the rows. So this will give me the characters, because I want to go from character to some index, right? I need to say what the index is. Now how can I find the index? I can just create a temporary variable here, say index. I can start with 0, right? So now I can assign that index, but I have to make sure that for the next iteration the index need to be incremented. So I say index plus equal to 1. So this way my index every time gets incremented. So now I have a key and a value, proper values, right, for the index. Okay, so after this iteration I can just return my index dictionary. So now I have a way to find out what the index for a character is. So let's create that up here. Create index dictionary, again pass in the first row. Now I have this index dictionary. Okay, so now I have all these things. Now what I want to do is I want to convert this this plain text string and key string into a list, right? Because right now it's just a string. I need to convert it into a list. So let's write a function that converts it. Okay, convert string to list. There are many ways to do this, but we will go with the rudimentary approach that we know, that we have used before. Okay, so here we say string or list of string. So I'll create a new list, empty list, and I will just iterate through my string. Remember in the last class I said string is kind of like a list, right? You can iterate through the contents. So we do that here, and then list of string append C. Okay, so now we have a list of string, each list of characters, right? So return a list of, actually we should call the list of convert string to list of characters to be more precise. It's always very important to name your variables of what it represents. Okay, you don't want to name them like list1, list2, okay, because it's very hard to for someone else who's reading your program. Even for yourself, after like 1 month or 1 week, you come back and you try to read it and you see all these variables named list1, list2. You don't know what it really represents, right? So this way I know it's a list of characters, and I'm iterating through the string and then putting those characters into the list. Okay, this is just one way. There are other ways of doing it, but we don't have to worry about it because I want you to know the fundamentals of what's happening. Okay, so knowing this, why don't we create a function that does the encryption? Okay, so I'll call this encrypt. Obviously I need the key and the plain text, right? And I also need the grid, right? And also the let's say because I created the index dictionary, I'll pass in my index dictionary as well to my function here. What I'm expecting it to return is the encrypted text. Okay, so let's do this. So first I will convert my key into key list. Okay, a list of characters. So key list, I will say convert string to list key. Then I can do the same thing, plain text list. Convert string to list. I should name this more convert string to list. Convert string to list. Okay, so now it's everywhere is updated. Okay, it's just a handy way of doing so you don't miss anywhere. Okay, so now I have a key list, I have a plain text list. Okay, so now what I need to do, I need to go through each character in my plain text, right? So let's do that. So for let's call this P, plain text, okay, or T in plain text list. Okay, that's my T, and I can get the index for what that represents. So index, I will say I can use the index dictionary and pass in the character to find the index. So here index will be the integer. Okay, so this index is actually, let's call this let's say if we use the plain text as the row index, we'll call this row index. Okay, now how can I get the key index? So obviously it's going to start with 0, right? And then it's going to go 0 1 2 3, but the key list might be smaller than the plain text list, or vice versa. The plain text might be smaller than the key list. If plain text is smaller than the key list, then we don't have to worry about it, right? Because obviously there will be more characters in the key than the plain text. But suppose most of the time the plain text is going to be bigger than the key list, right? So I need some way of indexing back to the key list. So for example, let's take an example here. So if my, oh, it's too big. So if, what's wrong with this? All right. So if my key here, this is my plain text. So what do we have? Attack at dawn. A T T. And so forth, right? And my key, lemon, right? LEMON. Okay, so obviously up to 0 1 2 3 4th character we are good, we have a match. But soon as we go to the 5th character, we don't have a match. The key is because it's shorter, right? So we need to go back to the 0th position. So 5th has to go to 0, 6th have to go to 1, and so forth. So let's do it this way. So we will create a counter here, or we'll call this index. Okay, general index starts with 0. Okay, so we have the row index. To get the plain text, key itself, we will say key list at index. Okay, so for first iteration it will be the first character. Now this is just gives me the key character, right? Now I need to get I can pass it to my index dictionary to get the index. So my column index would be index dictionary at my key list at this index that I have a temporary index going. So I'm going to go from 0 to 4. The index, I'm going to increment the index every time by 1, right? But I need to be careful here. So soon as I reach the index the same size as my key, I need to reset my index to come from 0, 1, because I'm only using this index to index into my key list. Okay, I'm not using the index anywhere else. That's what I'm using. Okay, so I'll keep incrementing, but soon as index, so if index equal to the length of the key list, right? Key list index would be 4. So as soon as it's 4, as soon as it's 4, or as soon as it's greater than, if index greater than, right, as soon as it becomes greater, as in 5, I need to move it back to 0, right? So I would say here, if that is the case, I would say index equal to 0. So I'm just basically I'm resetting the index back. Okay, do you guys understand? Yes, no? Okay, so
What's
now,
the pass?
yeah, I'll get that. Remember I mentioned pass does nothing?
Yeah.
Yeah. So because we had nothing, we started with nothing, I just put pass in there. It doesn't mean, it doesn't do anything, pass. I just got rid of this. Okay, so now I have the row index and column index, right? So now in order to create my ciphertext, I just need to go into my grid based on these indexes and grab that character, right? So I will create a new list here, so call ciphertext list. Initially it will be empty, right? So having the row and the index, I can say grid add row index and then column index, right? That will give me the character in the grid that corresponds to the ciphertext, and I will add it to the ciphertext list append. Okay, so I keep appending to the ciphertext list. Once that all of that is done, right, I have my ciphertext created. I just need to return it as a, I just need to join them. Remember the last class I said how to join characters into a string, right? So I can use this method here. So I say I'm going to join based on the empty string, and I'm going to pass in my ciphertext list. Okay, so this should give me back my ciphertext. Let's see if it works. Hopefully it works. I didn't make any mistake. Let's see. So I have a plain text string. I'm going to pass into my function encrypt. I pass in my key string, plain text string, and my grid, and my index dictionary. Okay, so this should return me back my ciphertext. Okay, so let's print that. What do we need to print it as? Ciphertext. Okay, so print ciphertext, and I want to put these quotation mark around it so we know exactly what it is. Okay, so let's run this. So I'm going to encrypt, key is lemon, and attack at dawn. Okay, so some issue. Let's see what issue is this. So it says list index out of range, and it says index dictionary key list index. So let's go to that line. So something here is wrong. So I'm saying
you don't add 1 to the index every single time you go through the loop.
We do.
Oh, I didn't see that. Sorry.
Yeah. So what's the problem here? List index out of range. List index. Which list it is? It's this list, right? Key list. I'm thinking it's key list. So key list, convert string to list, key. Oh, actually, what did I pass in? Key string. Yes, key string, plain text string. Okay, so let's debug this. Okay. Encrypt. Key is lemon attack at dawn. Okay, so key lemon plain text attack at dawn. Grid. Yeah, looks. Let's see if grid is okay. Oh, it's here. So it's A, B, looks good, right? All the way to Z, and it ends with Y. Does it? Let's just check. Yeah. All right. So what else? Grid is looking okay. How about the index dictionary? Yeah, that looks okay too, right? 0 all the way to Z, 25. Okay. Now key attack at plain text is okay. So we come down here. How about these list? Key list. Key list is good. Plain text list is also good, right? This one. Now index starts at 0. Now I'm going to get my text, right? So first it should be A, row index should be 0, column index should be, so key list at 0. So it should be K, and depending on what K corresponds to, it's 11. Or sorry, but depending on what L corresponds to, it's index 11. Okay, so now here I'm saying row index, column index, that should be good. Okay, so I think it's something here. If it is, so if index is greater than, and I need to set it back to, yeah, that seems okay. So my index is now 1. What's my index now? Index is 4. That is still going to be okay. Now when my index becomes 5, this should set, oh, why it doesn't go in there? It didn't go in here. Alright, so let's see. Length of key list. What is my key list? Key list is 5. 1, 2, 3, 4, 5. So if index is 4, so I should say equal. You know why? Because if it is 4 up here, that's good. If it becomes 5, I should set it back to 0 because I don't have any fifth index, right? 0, 1, 2, 3, 4. Okay, so that was the mistake. Okay, so let's run this again. Encrypt key lemon attack at dawn. Alright, so does that match? In fact, it does match. LXF4 PRNHR. Okay, so I think we have the index, encryption going. Now, how do we do the decryption? A lot of you were getting tripped up by this. So we just have to do the opposite of what we did for encrypt. Okay, so if we take out our square, the key doesn't change, right? So we can index into the key, right? For example, here, let's say A, for example. If I index into this row by that key, then I need to go and find till I find the letter that matches the I did it this the opposite way. So if I find the key, right, okay, so it doesn't matter. I think I did it the opposite way, but it doesn't matter. So let's say, assuming this is the key, attack. So we go in and first find the row, and then in the row we need to iterate through to find the matching letter of our first character in the encrypted text. Okay, so soon as we find that encrypted text, we just need to go up and see what index we used, right? um, because we would have used some text to get into this index, right? So once we know the index, we need to go back and see what the character was for that index. So we need some sort of a reverse lookup, but the reverse lookup is basically the first row. So if you go to the first row and use that index, that will be our reverse lookup, right? So we came from a letter to an index. Now we're going from a letter, so we find the index and we're going back to a letter. Does that make sense? So we need a reverse lookup, okay? And it is simply lookup on the based on the index of the ciphertext that we find in the row. That is basically, we just have to go to the first row using that index. Okay, so that will be our reverse lookup. So let's do this. So decrypt, we need to take in the key again. This one we will get the ciphertext, grid, and then index dictionary. Do we need the index dictionary? Yes, because we need to go by the keys, right? So what I need the key list again, right? That's how I first index into the row. Then in this instance, I don't need the plain text, but I need the ciphertext. So I need to convert the ciphertext to a ciphertext list. Okay. So now again, I need let's see how can we do this. So we will go key by key, or sorry, we need to go letter by letter in the ciphertext, right? For C in ciphertext, okay, I need to find out what the index for that ciphertext is. Sorry, do I need to go ciphertext? No, I need to go key by key, right? Because that's the only thing I know. I don't know. This is the output of my encrypt function, right? So it is let's go back to, it is some value in this grid, right? So this value won't give me the index for what I need to look for. I can use the key index, right? That'll give me my row, right? Because I used up here, I used the key list and I found out the row index is actually the I used the row index as the plain text index, right? Now it doesn't matter which index I use because it's symmetric. I know for sure that if I use the key index, then I'm good. I just need to go into the key index, then I need to iterate through to find out where exactly that character, the ciphertext character, occurred. Okay, so I need to go by ciphertext, but I need to have the right index for my key. Okay, so index again, key would always start with 0. So how do we get the index? So we get the index So my row would be grid at the index. Okay, so now I have at this point I have the index. What am I doing? So sorry, not the index. This is not the index. I want the index from the index dictionary, because yes, index dictionary of the key list index, right? So this is my key list. Where's my diagram? My key list.
Why do you want index from the index dictionary?
Because I have a character, I need to find out what the index of that character is. So that's why I have a dictionary. Okay, so we need to go for this key. I need to see this value L. I need to find the index for that, and that'll be my row. Okay, so that's what I'm doing here. So key list at that index. Okay, that's a key list index. That character, I need to use that character and go into my index dictionary to find out what row of the grid that I need. Okay, again I need to do the same thing I did here. I need to make sure that my index that I index into the key list doesn't run over, right? So I need to make sure that if the index is length of the key list, I set the index back to 0. That's what this. So this index is basically my index into the keys. So now I have the row, right? I need to see where that ciphertext occurred in that row, right? So then I can use that index to find out what the actual original input text was. Okay, so how can we do this? I have the row. I can say row index of, remember that function that we used a while back to find the index of some occurrence of something? I can say that, right? Now why is this thing index of not working? Grid index of dictionary key list index row is any.
It's row.index, I think.
Yeah, but I don't know why it doesn't. Yeah, I don't know why it doesn't give me. Okay, anyways, I think it's because we're doing too many. So let's just break this apart. Okay, so let's call this key index or key character. Let's call this k equal key character. So this is cipher character and this is key character. So key character will be key list at index. Right, and then key index would be
There's no semicolon.
Oh, index dictionary at that key. Right, so now index diction is not used. So now we can use the k index to go into grid. Okay, now the row still shows me as any. Probably doesn't. Okay, that doesn't matter. So this is more. I hope this is more understanding. Helps you understand. So we go into the key. We go the index is 0. Find the key, first key, and find the what the index for that key is based on this our dictionary. So we get the key index, and using that we go into the grid to find the row. Now in the row we need to find out where in that row what the index for that character is, right? The ciphered character. So if you know this index. So let's call this is the plain text index. Okay, so using this index, I just need to go to the first row and use that index. That will be my original character. So let's do this. So I will create a list, plain text list. So this will be grid at 0, the first row at plain text index. That will give me the plain text character. Now I can just simply append that to my plain text list. Okay, so after end of this iteration, I would have my plain text, which I can return, similar to how I returned that one. Alright, so let's see if this works. So in here I would ask cipher text. What did we say? Enter cipher text. Yeah. Then I can call my function decrypt, pass in my key string, cipher string, cipher text. Okay, cipher text string, similar to plain text string. I just want to name it, and then I pass in the grid and the index dictionary. So this should be my plain text. Then I can just print out, just copy this thing. Let's see if this works. Hopefully we didn't make any mistake, but even if we did, that's okay. Let's do this. Decrypt. So what was the, it should have been something like this.
The key's lemon.
Key, first key. Lemon, ciphertext, we get the plain text back. So it's working. Right? So let's see if we can clean up this code a bit. I don't like this, what we did. Yeah. So what did we do here? Ciphertext list. This is not used. Convert string to ciphertext. We don't really need the ciphertext list. We can just go through each. So we don't need this. Right? So we have the text. For each text, we first need to find out what the corresponding index for the key is, right? So we get the key in character, and from the key character we get the key index, and using the key index we go into the grid to find out what the row is, and then we find out in the row what the index for that ciphertext is, right? That will give us the index that we need to use to find out what the plain text is. Plain text is basically when we go up to the first row and use that index to find the plain text character. Does that make sense? Then we append the plain text character into our list, and here we just adjust the index for the key in case it overflows, and at the end of this loop we have the plain text list of characters, and we just join those to create the string. Okay, now the question was, first do it with ABCD Next, all we have to do is we just have to add the rest of the characters, lowercase characters. And then 0 to 9, and then the space. Space is also a character. So if we have this, it will just run through everything, because everything that we did is based on the size of the characters, right? Because we just get the first row, right, based on the first row's length. So we did everything based on that. So everything should be working. Okay, so let's run that. See, so we said our example, what did we say? Encrypt key is Python, plain text is Python coding kids. That should give me, yeah, correct. Now if I want to decrypt this thing, copy this thing, Command C, Command V, enter.
That's the
Wrong. Bad. Encrypt Python coding kids. Okay, so decrypt Python. Now we pass in the Command C, Command V, enter, Python coding kids. Hooray! That's it. That was the assignment. It's a little bit challenging because especially the decrypt, right? The decrypt was kind of confusing. How do you go back? Basically, we just need to match up the ciphertext with the key, and then use the key character to go into the indexed. We need to index into the row using the key index, and then we find out where in that row does the ciphertext occur. And then once we find the index of where the ciphertext occurs, we just go to the first row and use that index to find out what the plain text was, because that's how we came, right? Initially we use the plain text indexed and the key index to come to the value of the ciphertext, right? So that's the way to do this. So I have a question. How are you guys finding these assignments? Is it getting challenging, more easier? I know it's getting challenging, right? So I'm thinking that I'm not going to increase the difficulty anymore of the assignments for a while. We're going to do more assignments like this. I want you guys to get comfortable with this iteration, indexing, because these things are going to happen again and again. Okay, you have to be very good at this. So next assignment also, I'm thinking that it should be based on this. Okay, indexing and creating a list of list. Basically, the list of list is called a matrix. Okay, in mathematics. So computer programming is, a lot of it is math, right? Not like, yeah, well, you have to know math in order to program. Okay, so hopefully this didn't confuse you guys much, the decryption part. First of all, who understood the problem, the decryption?
I did.
Yeah, okay, that's good. So
I did.
Yeah,
I did.
all right, cool. So it wasn't that difficult then, because I think we kind of explained it right before we gave the assignment. So the tricky part was going back. Question for you guys: suppose Python didn't give us an index function. How can we write our own index function? So remember, row is a list of characters, and this is a character. I want to find out which index that character belongs in that row. How would I write this function?
Use a for loop and access to the list and look until it's equal. The position is equal to C, and just keep on adding 1 to the position.
As soon as you find the match, you just return the index that you are incrementing, right? Then you have the index. So that's one way of finding it. What about another way? Always, even this index, I'm pretty sure that it's implemented something like that. It goes through the list, right, and finds the index. So can you guys think of some other way where we don't have to iterate through the list? Because when we iterate through the list, we are spending CPU cycles, right? So the more CPU cycles we spend, the slower our program becomes, right? So is there a way that we can we don't have to cycle through the list or iterate through the list, but somehow instantaneously find out the index for this character? Does anything ring a bell? Do we know anything that gives us something right away based on some key?
Dictionary.
Yeah, dictionary, right? Dictionary is it's you don't have to iterate through. You just give the index or whatever the index key is and gives you back the value right away, right? So how can we take advantage of that for this part here to find out what that character, where in the row does that character belong, the index? Anyone have any ideas? Basically, we want to speed up our program. The decryption is too slow. How can we speed it up? Any ideas? I just gave you a big clue. Dictionary, right?
You can use the dictionary and name each letter, the index the same letter. That's what I did. I named each index from the letter. So then you can index that, and then you can put the letter in the dictionary and get the index out.
So let's go back to our grid. So every row except the first row, right? First row, let's assume it's the first row. If it is the first row and I need to find out where some character occurs in the first row, I already have my index, the index that I created. Sorry, not in and the dictionary that I created. That dictionary would tell me right away, if it is the first row, it'll tell me what is the index, right? Now, that is for the first row. What about the second row? So what if I created a dictionary for each row that will tell me whatever the character is. So I can create a dictionary per row that has a key and value for each of these characters. So B would be 1, sorry, so here A would be 0, B would be 1, right? But for this row I would create a dictionary where it says B is 0, C is 1, and so forth. So I will have for each of my row I would have another corresponding map for each of these rows. I could do that, right? That will right away tell me. So if I go into this row and I get the corresponding dictionary for that row and use that letter in the dictionary to find out what the row is. So find out the index. I could do that. That's one way of doing it. Sorry, I didn't understand what you said, Bailon. Is that what you were saying, or how did you do it?
Yeah, I made an index for each row. That's what I did. When I made my board, I made an index for each row,
Yeah.
and then that's how I accessed the rows. I didn't get an index. I just so horizontally I used the index, and horizontally I used the key or the index in the dictionary, and then vertically I used the index because I couldn't get the.
So you had a list of, you had a dictionary of rows.
Yeah, my board was a dictionary. It wasn't a list of lists.
Okay.
It was. I did it as a dictionary.
So you had a dictionary, and then in the dictionary, what was your key? Key was the character, or
In my dictionary.
your key in the dictionary. Remember, dictionary has a key and a value, right?
Yeah.
What was the key in your dictionary?
So I had a. Can I share my screen? Actually, that would be easier.
Yeah. No, you just tell me. I need to know
Okay.
whether you understand what you wrote.
Okay, so I used I just had a range. I made a table for all the stuff in like the A, B, C, D, E, F, G. And then I had a list for that. And then from that list, I had um I had a row, or I had a variable that's equal to 0. And then
but my question is, you said your board was a dictionary, right?
yeah,
What was the key in that dictionary?
the first letter A, B, C, D,
So
E, F,
your
G.
letters were your keys. So you had
Yeah,
A, B, C, D, E, F, G, all these guys as the key, and
yeah.
the row was, what was the row? Row was A, B, C, Ds, right? Had to be.
Yeah,
And
but I had to use an index for the columns to find like vertically. But I used the dictionary, like I assigned um the key of the dictionary was the same as the first one in that row. So for the first line it would be
so it'll be A, B, C, D, E, F, G, H, I, J, K, right?
yeah.
Yeah, that's the first. No, I just want you guys to see how would you. So once you see this kind of a grid, doesn't matter how you represent it, but you have to have an understanding that how are you structuring this data in programming, whether it be list or a map, and how do you traverse it, that you should know. Okay, so if you create a map, okay, I will use the character as my key to find out what the row is, right? And then what was the data structure for your row? Was it just a list of characters?
So then the other way, yeah, it was just a list of characters, and then the other way I had to use an index.
What do you mean you had to use an index?
Like I had to, so so I had the dictionary, and row 1 was A, row 2 was B, C, D, and then while I encrypted, I had to get the position of the key, and then I had to make them meet. But the key wasn't. It wasn't. It was a number. Like I had to use like 1 or 2 or 3 or 0.
Okay.
I couldn't get that one to
So
be a letter.
did you have a dictionary of dictionary, or just dictionary of list?
Oh, I had a dictionary of lists. I thought, oh, okay. I had a dictionary of lists.
List, right? And
Yeah.
Okay.
Wait, if I use a dictionary of dictionaries, I could have gotten. Oh, okay. That makes more sense. Wait, can I access it the other way? If I use the dictionary of dictionaries?
Yeah, so dictionary key would be your characters, and the value would be another dictionary.
Oh, okay. Okay.
Yeah. So there's lots of ways of doing it, but I want you guys to understand what this data structure means. What is the list and what is a dictionary, and how you can use, because remember, the items in the list or the dictionary can be anything, right? So it can be a list of, like we had list of list, or list of dictionary, or dictionary of list or dictionary of dictionary, and then it goes on. Like there's no restriction. Like you can use all of these to solve a problem. Some problems, like if you don't use up memory, so every time you use a dictionary of dictionary, it's going to take up more space in memory. So what you gain for that is speed. Whereas if you don't have that in memory, you have to use CPU cycles to figure out where that character occurs. So it's a trade-off, speed versus memory. Okay, so that's a key takeaway there. All right, so any questions? Krishna, you've been quiet. Where were you struggling?
Just the decrypting on when there was multiple like ABCD, like the lowercase ABCDs.
Okay. So yeah, that's another thing. So once you figure out this, that's why I asked you guys first focus on just the capital letters, because the rest of it is just like you're basically extending this matrix, right? So once you figure out this encrypt decrypt, you don't have to worry about how many characters you add to the row. It's all the same. So size here doesn't really matter, but so you have to figure out the algorithm first. Once you figure that out, the size here, I can keep adding whatever characters that I want to support in my encrypt decrypt, and my algorithm would still work. It's not dependent on the size of this, like as long as it's unique, right? What else? Any other questions? What about how are you guys finding? Are you finding difficulty in like breaking up the program into smaller pieces? Like the examples why I give is I want you guys to see how I break up a bigger problem into these smaller functions that are manageable, right? When I look at a function, it shouldn't be bigger, no bigger than like this one screen, because if it is bigger than one screen, then I won't be able to comprehend what it does. Like you don't want to put everything in one main function, right? That just gets too complicated to read and also to test. Actually, next class I want to go into how to test this. I remember I told you guys that writing a program to test your program, right? So basically it comes down to testing these functions to make sure that it behaves as it should. So it's like it's like the very basic. You have to test every single function to make sure that whatever the input that you give, it gives you back the expected output that you think. Once you ensure that, then your main program, you will have less difficulty finding out bugs, because you are guaranteed that all those smaller functions are working as you expected to. Then you can narrow down where your problems are. Okay, I think that's one thing that people don't teach. I want to teach you guys. So it's called unit testing. So it's testing your program. It will make your life much more easier. And even like you don't have to worry, like you write something and you change it and all of a sudden your program breaks, right? Sometimes you would have run into that and you'll be like, oh, what did I change? Why did it break? So if you write your test cases for these smaller functions, then you can be very confident that whatever you change is like where you will easily be able to find out, because the test cases that you write will be able to tell you what you broke. So that's another concept. Okay, so that we're going to learn about that tomorrow. Okay, so the more, again, as I said, the more problems that you do, the better you become at. So from the first assignment that you guys did to this assignment, are you guys finding that you are improving? Yeah. All right, that's the important thing. All right, that's it for today. Bye guys.
Bye.
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 Bye bye.